In this video, we're going to talk about standard G-C.2. This standard states that we should understand and apply theorems about circles. We need to be able to apply theorems about relationships with angles and circles, including central, inscribed, and circumscribed angles. We also need to understand and apply theorems about relationships with line segments and circles, including radii, diameter, secants, tangents, and chords. So let's look at 4 questions that relate to this standard. In question number 1, it says in circle P, EG is a diameter. So let's highlight EG to help it stand out a little bit. So they're saying that is a diameter, and they want to know what is the measure of arc EH. So arc EH is right there, and they just want the measure of the arc. So that means, like, what is the degree measure of it? We don't have to find the length of the arc. That is different. They sound a lot alike, but they're not the same thing. So we know that this diameter would break up our circle and make this side equal to 180, and then we already know we have 132. And so the central angle and the arc EH would both be equal to 180 minus 132, which would just leave us with 48 degrees. So that is option C. All right, let's look at question number 2. The diagram shows circle T. What is the radius of circle T? So what we see over here is we have an inscribed angle that's sitting on the edge of the circle, and it opens up to half of the circle because we can see that they've given us this diameter NW right here. So when we have an inscribed angle that opens up to 180 degrees, it's always half of that, because the inscribed angle is always half of our intercepted arc. And so therefore we know this is a 90-degree angle, and therefore that's a right triangle. So we're able to use the Pythagorean theorem to help us figure out the diameter, and then we'll be able to just divide that by 2 to get the radius. So it doesn't matter which leg of the triangle you start with. So I'm going to start with just the 105 squared plus the 56 squared equals c squared. And then I've typed these in the calculator to save a little time, and you get 14,161 is equal to c squared. And then when you take the square root to get c by itself, you get 119 would be c. But in this case, that's the diameter, and they just want the radius, which is half of that. And so when you divide that by 2, you get the 59.5, which is option B. So the radius, I'll just write that out, is 59.5. All right, so let's take a look at the next question. It says in circle O, PQ and RQ are tangents. So that's important because that helps us know that our theorem about tangents would apply here. And our theorem is the angle that sits outside the circle, like angle Q, which is what they're asking us to find. They said, what's the measure of that angle? Will be equal to half of the big arc minus the little arc. So this is definitely the big arc out here. This big arc. So half of the big arc minus the little arc. Let me get a different color. The little arc is right here. And that is created by these 2 tangents. So they cut through the circle right there where it creates this little arc and this bigger arc. And the theorem is that half of the big arc minus that little arc, let me write that in a different color, would equal the angle. So let me write that theorem down. The angle that sits outside the circle, like angle Q, where those 2 tangents meet on the outside, is equal to half of the big arc minus the little arc. Now, they've given us the big arc is 4x minus 38, and the little arc is x plus 10. So we don't know what they are yet, but we can figure them out because we know that those 2 combined would add up to the whole circle, which is 360 degrees. So let's just do a little work to figure out what x is. So we could say 4x minus 38 plus x plus 10 equals 360, and that'll help us figure out x, and then we can plug it back in to know the measures of those arcs, and therefore we can figure out the angle, because when I look at my answer choices, it's not in terms of x, which tells me I've got to get a number for the angle, not an expression. All right, so if we combine like terms, we have 4x plus x would give us 5x. Then we have negative 38 plus 10 would be negative 28 is equal to 360. Then if we add 28, we get 5x equals 388. And then we can divide both sides by 5, and that gives us a decimal of 77.6. I typed it in my calculator. So now we just got to go back and plug that in to get what is the big arc. So that'll be 4 times 77.6 minus 38, which equals, let me move the word big out of the way. So that would equal 272.4 degrees. And then our little arc, let's plug this in over here, would be 77.6 that we found for x plus 10, and that's just 87.6. So now we can finally put all of that together and say our angle Q is going to equal, so the measure of angle Q is 1/2 of the big arc, which is 272.4, minus the little arc of 87.6. So therefore the measure of angle Q is going to equal 92.4. You can just type all of that in the calculator. So 92.4 is our answer, which is D. Okay, let's look at the last question. It says the diagram shows circle M. What is the value of x? And we notice our answers are in decimals. And then when we look at this circle, we have 2 intersecting chords inside this circle. And so the rule here is we take the ones that are on the same chord. So let me highlight that permanently. So we can take this piece times this piece of this chord, and we can equal that to the other 2 pieces on the other chord multiplied together. So 48 minus 6x times 12.25. So to set this up, we can say 5, let me get my pen. 5.25 times 31x minus 5 is going to equal the 48 minus 6x times 12.25. So I'm just going to put the 12.25 in the front, since we normally write it out front and distribute it. So notice I've taken the 2 pieces that are on the same chord. So this little piece times the one that's on the same chord is equal to the other chord multiplied together. So this one times this one. And now we're just going to figure out what x is. So we have to distribute the 5.25 and the 12.25. And those being decimals just makes it a little bit more challenging, but nothing you can't handle. So we get 162.75x minus 26.25 on the left. And then we get 588 minus 73.5x on the right. Then what I did was add 73.5x, because we want to put the variables together. And so that gave me 236.25x equals, and then I'm going to add 588 stays over there, but I'm going to add the 26.25 to the other side. And then I get 236.25x is equal to 614.25. And last but not least, I just need to divide out the 236.25. And x equals 2.6 meters. So when I go back over here, they just gave me 2.6 was C. All right, so that's it for this standard.